Now let's take up questions from exercise 19. So the first question. On dividing a number by 56, we get 29 as the remainder. I hope you remember dividend n is equal to divisor into quotient plus remainder. Here the number n can be written as dividing by 56. So divisor is 56 into q plus remainder is 29. Now the same number has to be divided by 8. As you can see, 56 is divisible by 8. 8 sevens are 56. So this 56 into q will not yield any remainder on division by 8. Now 29 is not divisible by 8. So whatever remainder we get it from 29. So divide 29 by 8. 8 threes are 24. So remainder would be 5. So 5 is the answer of this question. Simple one. Second question, on dividing a number by 357, we get 39 as the remainder. So the number can be written as 357q plus 39. Now divide the same number by 17. Now if you check, 357 is divisible by 17. 17 twos are 34 minus, so 1 and 7. So it is divisible by 17. So this part will not give us any remainder. Right? 39 is not divisible by 17. So whatever remainder comes, it comes from 39. So 39 divided by 17, remainder would be 17 twos are 34, remainder would be 5. Alright. Then question number 3, it says on dividing a number by 722, we get 21 as remainder. Very clearly the number can be written as 722x plus 21, right? You can take any number like that. Now, when the same number is divided by 19, first you need to check 722 whether it is divisible by 19 or not. So 19 3s are 57. So subtract 72 minus 57, you will get 15 152. So 19 8s are 152. So right. So 722 22 is divisible by 19. That means this part will not give any remainder when divided by 19. Only remainder will come from 21. So divide 21 upon 19, 21 by 19, find the remainder. 19 ones are 19, so 2 will be the remainder in this case. Now let's take the next question. It says question number 4, when a number when divided by 296 leaves 75 as the remainder, right? Same process, n is equal to 296x plus 75. So first check 296 whether it is divisible by 37 or not. So 37, how many times can it go? 8 times. Check, 8 sevens are 56. 5 remain, 5 carry forward. 8 threes are 24 plus 5 29, right? So it is divisible. So 296x will not give us any remainder when divided by 37. The only remainder that will come from 75. So divide 75 by 37 and find remainder. 37 twos are is 74. So the required remainder would be 1. The remaining would be 1. Alright. Now we come to question number 5. This is a slightly tricky question again. It says it is being given that 2 raised to the power 32 plus 1 is completely divisible by a whole number. So that whole number can be any factor of 2 raised to 32 plus 1. Right? So let's say the number is any factor. Let's say our number, that whole number that we are talking about is equal to any factor of 2 raised to 32 plus 1. Okay, any factor of 2 raised to 32 plus 1. Now the question is asking which of the following numbers is completely divisible by this whole number. That means which of the, I'll if you repeat the question, it says which of the following numbers is completely divisible by any factor of 2 raised to 32 plus 1. Right? We need to find an option which is divisible by any factor of 2 raised to 32 plus 1. Now look at the first option. It is 2 raised to 16 plus 1. Now 2 raised to 16 plus 1, visibly it is smaller than 2 raised to 32 plus 1. So it cannot be divisible by all factors of 2 raised to 32 plus 1. Same goes with B option. It is 2 raised to 16 minus 1. This also is smaller than 2 raised to 32 plus 1. So it cannot be divisible by all factors of 2 raised to 32 plus 1. Right? because one of the factors of 2 raised to 32 plus 1 is the number itself, and that has to be a factor of the correct option. So neither A, neither B can be the answer. Same goes with C. C option is 7 into 2 raised to 23. Definitely this also is smaller than 2 raised to 32 plus 1. Hence this cannot be the answer. Right? Now D option is the only one. Hence it will be the answer 2 raised to 96 plus 1. This has to be the correct answer. And there is another explanation for D option. Let's check the D option again. 2 raised to the power 96 plus 1 can be written as 2 raised to the power 32 into 3 plus 1 raised to the power 3, which can be further written as 2 raised to 32 whole to the power 3 plus 1 to the power 3. And we have seen earlier that a cube plus b cube can be factorized as a plus b into a square minus ab plus b square. All right. So from there we can factorize this as 2 raised to the power 32 plus 1 into 2 raised to the power 32 whole square minus 2 raised to the power 32 into 1 plus 1 square. So clearly this number 2 raised to 96 plus 1 is divisible by 2 raised to 32 plus 1. Hence it is divisible by all factors of 2 raised to 32 plus 1. Alright. So the answer is D option. Answer of the question would be D option. Okay. Now let's take the next question. Question number 6. It says which of the following numbers will completely divide 49 raised to the power 15 minus 1. We can write this as 49 raised to the power 15 minus 1 raised to the power 15. Now in the theory section, we have studied that anything like a raised to n minus b raised to n is always divisible by a minus b into something. Let's say k. That means it's 49 raised to the power 15 minus, this relation is true for all n which are natural numbers or which are whole numbers, right? So 49 raised to 15 minus 1 raised to 15, it must be divisible by 49 minus 1 into something. We don't bother about the something part. 49 minus 1 is 48. So one thing is very clear, that this number is definitely divisible by 48. So answer is 48. Right? Important thing is this relation that a raised to n minus b raised to n is always divisible by a minus b. Right? We have also done it for plus sign. A raised to n plus b raised to n is divisible by a plus b only for odd values of n. But a raised to n minus b raised to n is always divisible by a minus b. Right? So here the answer option is C option. Okay. Now question number 7. Now 67 raised to the power 67 plus 67 divide by 68. Right? Very simple question. How do you find remainder? We'll straight away find remainder one by one. Let's see. If it is only 67 divide by 68, remainder would be minus 1. 67 has a power of 67, so remainder will also have a power of 67. So from the first part, that is 67 raised to 67, we have got the remainder as minus 1 to the power 67 plus from the second part, that is only 67. Now when this only 67 is divided by 68, remainder would be minus 1. Alright, this we have done in theory section. Now minus 1 to the power 67, odd power of negative number will remain negative, so it is minus 1 plus minus 1, so it is minus 2. Now the answer of a remainder question cannot be negative, so what do we do now? Whenever we get a negative remainder, I hope you remember, add the divisor to it. So required remainder would be minus 2 plus the divisor, that is 68, which is 66. So the answer of this question is 66, which is option C. All right. You know, I'll just take it like this. Suppose if it is 68 upon 68, what will be the remainder? 0. What if it is 69 upon 68? What will be the remainder? 1. What if it is 670 upon 68? Remainder will be 2, and so on. Similarly, on the lower side, if you divide 67 by 68, remainder would be minus 1. If you divide 66 upon 68, remainder would be minus 2, and so on and so forth. That is what we have utilized in this question. Okay. Now let's take question number 8, which is what is the unit digit in 6374 to the power 1793 into 625 to the power 317 into 341 to the power 491. Now, first of all, if you have to find the unit digit, consider only unit digit from the numbers, right? So it is 4 here, 5 here, and 1 here. Now, if you remember, 4 to the power odd number, unit digit is always 4. 4 to the power even number, unit digit is always 6. Now, in this question, it is 4 to the power odd number, so it has to be 4 into, now 5 never changes whatever is the power. So 5 to the power anything, unit digit is always 5. 1 to the power anything, the unit digit will always remain 1. So 1, 5 and 0, they do not change. So we directly have calculated the unit digit, that is 4 into 5 into 1. Now 4 into 5 into 1 is 20. So unit digit is 0. So our answer of the question would be 0. Alright, just be careful in looking for the options. Okay, so if you are asked the unit digit, focus only on the unit digit. Now let's take ninth question. So in the ninth question, it is 637 to the power 1793 into 62 to the power 317 into 39 to the power 491. Now here it is 7, here it is 2, and here it is 9. Right? For 7, there is a cyclicity of 4. Right? That means every fourth power of 7 will have the same unit digits. And the unit digits in the powers of 7 are 7. 7 to the power 1 is 7. 7 square is 49, so 9. 7 cube is 343, so 3. 7 to the power 4 is 2401, so 1. And again 7 to the power 5 would be 7, 9, 3, 1 and so on. It will go on in groups of 4 powers. Right? So here if you divide 1793 by 4, you need to consider only 93. 93 divided by 4, remainder is 1. So unit digit of the first number would be 7 raised to the power 1. Right? I hope you have done the theory section. Go back to that and check it again. For 7, cyclicity is 4. So divide the whole power by 4. Divisibility test of 4 tells us that divide only the last 2 digits. So last 2 digits of the power are 93. 93 divided by 4, remainder is 1. So unit digit will be decided by 7 raised to the power 1 into the second one. Here it is 2. Again for 2 also cyclicity is 4. So whatever is the power is 317. Divide this by 4. Take only the last two digits of that power, that is 17. Divide by 4, remainder is 1. So unit digit will be decided by 2 raised to the power 1. You can check for 2 also. 2 raised to 1 is 2. 2 raised to 2 is 4, 2 raised to 3 is 8, 2 raised to 4 is 16, that is 6, and again 2, 4, 8, 6. Alright. Then for 9, 9 raised to the power odd number is always 9, ends in 9. 9 raised to the power even number, always unit digit is 1. So here it is 9 raised to the power odd number, so it is 9. Right. So our answer would be 7 into 2, that is 14. 14 into 9 is 126. So we have to consider only the unit digit from this number, that is 6. So unit digit in this question is 6. Look for the correct option. Alright. So in this question, if you look at the options, I think it is none of these. Okay. So option D is the correct answer. Now let's take up the next question, question number 10. It says 63 to the power 93 into 6 to the power 317 into 34 to the power 491. Right? Very simple question. Here it is 3. For 3 again, cyclicity is 4. And the powers, if you check the unit digit of the powers of 3, 3 raised to 1 is 3. 3 square is 9. 3 cube is 27, so 7. 3 raised to 4 is 81, so 1. And they keep repeating in this order. So here, how do we do that? Cyclicity is 4. So divide the given power by 4. Find the remainder. remainder is 1, so it is 3 raised to the power 1. 6 to the power anything never changes, it remains 6. 4 to the power odd number will always end in 4, and 4 to the power even number will always end in 6. Here it is 4 to the power 491, that is odd number, so it has to be 4. So 3 into 6 is 18, 18 into 4 is 72, so our answer will be 2 because the question is asking only the unit digit. So unit digit in this case is 2. Remember that we are concerned only with the unit digit, not the digits before that. Okay, let's take question number 11. It says, what is the unit digit in 68 to the power 70 into 63 to the power 31 into 34 to the power 4918? Let's see. For 8 also cyclicity is 4, right? So, and you can check the unit digits of powers of 8 would be 8. Then 8 square is 64. So 4, 8 cube is 512. So 2 and 8 to the power 4 is 4096, hence 6. And all the powers of 8 will have these digits only in that order. Now here the power is 17 divided by 4, remainder is 1. The unit digit of the first part would be 8 raised to 1. In the second one it is 3, and cyclicity of 3 we have already seen, it is 4. So 31 divided by 4, remainder would be 3. So it is 3 cube into, here it is 4, 4 to the power even number will always end in 6. So we have 8 into 3 cube is 27. So take only the unit digit, that is 7, into 6. Now 8 into 7 is 56. So consider only the unit digit of that number, 6 into 6, that is 36. So the answer of the question would be 6. Alright, so unit digit of this number is 6. So answer of the question is 6. Alright. Remember, if the question says what is the second last digit, you don't say 3, we don't know. We have calculated, we are focused only on the last digit, that is the unit digit of these numbers. Now let's take up question number 12. It says the sum of first 45 natural numbers. I think there's a direct formula for it. We have sum of the first 45 natural numbers, that is 1 plus 2. Natural numbers start from 1. So it is 1 plus 2 plus 3 up to 45. Right? So here the last number is 45. That is n equal to 45. And the formula is n into n plus 1 divided by 2. Where n is the last number. This is n into n plus 1 by 2 is the formula for sum of all the natural numbers from 1 to n. So just put n equal to 45. So it is 45 into 46 divided by 2. So 2 cancels 46 23 times. The answer would be 45 into 23. Multiply that. You will get it 900 and 135. So it is 1035 is the answer of this question. Very easy question. Standard formula based questions. Now question number 13. It says how many 3-digit numbers are completely divisible by 6? Now this is again a tricky question. There are two ways to do it. One is with arithmetic progression and the other is with basic counting of multiples, right? Now 3-digit numbers start from 100. Okay. Now the first 3-digit number which is divisible by 6 is 102. You have to calculate it. You have to check it. Let's say 100 is not divisible by 6. 101 is not divisible by 2. 102 is divisible by both 2 and 3. Hence it is divisible by 6. So 102 is the first number. So automatically the next number will be 108. The next number would be 114. The next number would be 120 and so on. Now look at the last number. If you just check, last number is 1000 is not divisible by 6. Before that 990 is divisible by 6. So 996 will also be divisible by 6. So last number that we have is 996. Right? Now you can see this is an arithmetic progression where common difference is 6. Alright, so our first term A is 102 and common difference D is 6 and the last term AN is 996. And from arithmetic progression we know the formula AN is equal to A plus N minus 1 into D. Now in place of AN you put 996, in place of A you put 102 plus N minus 1 in place of D you put 6. Whatever the value of n you get from here will be your total number of numbers. Now 102 goes to the left hand side, and if you subtract, it will get 894 is equal to n minus 1 into 6. From here you can see that n minus 1 is equal to 894 divided by 6, which is equal to 6 ones are 6, 29, 6 fours are 24, 54, 9. So n minus 1 is 149. So n is equal to 149 plus 1, that is 150. So there are 150 three-digit numbers divisible by 6. This is one way of doing this question. Now I'm going to discuss the other method of the same question, which is very important. You must know that also. So the other method for question number 13, would be, let's see. The question says how many three-digit numbers are completely divisible by 6. Now the other method depends on, let's say, suppose you want to find the multiples of 6 from 1 to 100. So how many numbers are there from 1 to 100 which are divisible by 6? That will be equal to last number divided by 6 and the integer part of that thing. Suppose you want to calculate the number of multiple of any number in any set starting from 1. The condition is the set should start from 1. So from 1 to 100, the number of multiples of 6 would be 100 by 6. That is equal to 16. The actual value will be 16.66, but because we are counting, it has to be 16. Similarly, from 1 to 1000, how many numbers are there which are divisible by 6? So it will be last number divided by 6. And that will come out to be 166.66. So it is 166. Now here we have to count the number of multiples of 6 which are three-digit numbers. So that means from 100 to 1000. So from 100 to 1000, the number of multiples of 6 would be, you can simply subtract 166 minus 16. Why? We don't have to consider these numbers. And these are a part of these numbers. Why? This is from 1 to 100. This is from 1 to 1000. But we don't need up to 100 because they would be two-digit numbers. Three-digit numbers would be above 100. Right? So this is the other way of doing the same question. So the answer would be 150. Still no difference. It will be 150. All right. Just be careful how the question has been asked. Okay. Now let's take question number 14. It says how many natural numbers are there between 23 and 100 which are exactly divisible by 6. Again, we can apply the same methods, same two methods. The first number which is divisible by 6, that would be 24. The second number would be 30 and 36 and so on. And the last number would be 96. You can still apply the arithmetic progression method, wherein you can say 96 is equal to A, that is 24, plus n minus 1 into D, that is 6. And from here you get 96 minus 24 would be 72 is equal to n minus 1 into 6. This will give us n minus 1 equal to 12 and n equal to 13. So there are 13 such numbers from 23 to 100 which are exactly divisible by 6. Alright. Now if you apply the other method, so answer is done. What about the other method? The other method says that here we need to count the multiples of 6 from 1 to 23. 1 to 23, how many the multiples of 6 are there? So 23 divided by 6. Now 23 divided by 6 would be 3 point something. So we take only the integer part because we are counting the numbers. And then 1 to 100. So how many are there from 1 to 100? Last number divided by 6. Now 100 by 6 is 16.66. So it is 16 numbers. And then you subtract. Why subtract? We do not need the numbers from 1 to 23. We need the numbers from 23 to 100. That means subtract 3 from 16. So the required number of multiples or required numbers which are divisible by 6 would be 16 minus 3, that is 13. So these are the two ways of solving the same question. Now let's consider question number 15. It says 11 square plus 12 square plus 13 square plus up to 20 square. Now see, this is a very interesting situation. We have a formula in which the numbers must start from 1 square. We have the formula for square of natural numbers starting from 1 to n, right? So let's do one thing. This is already 11 to 20. Let's add 1 square to 2 square, 1 plus square plus 2 square up to 10 square, and complete the whole thing up to 20 square. Right? So we have added 1 square up to 10 square and then subtract 1 square up to 10 square. There will be no problem. So whatever we have added, we are subtracting it. Okay. Now what is the benefit of this? If you see, the first part becomes all the squares from 1 to 20. The second part also becomes from 1 to 10. Now for both of them, we can apply the formula of this one, that is 1 square plus 2 square up to n square. The sum of squares is n into n plus 1 into 2n plus 1 divided by 6. This is the formula for sum of squares of natural numbers, right? So applying the same formula for the first part, you will have to put n equal to 20. So for the first part, it will be 20 into 21 into 20 into 2 is 41, 41 by 6 minus. For the second part, you will have to put n equal to 10. So it is 10 into 11 into 21 divided by 6. So formula remains the same for both the parts. So what we did, we had the squares from 11 to 20. So we added the squares from 1 to 10 and subtracted the squares from 1 to 10 so that both parts start from 1. Okay. Now calculate separately, or you can, whatever you can do, let's say if you take 21 by 6 common, let's say 21 by 6 common, inside we will have 20 into 41 minus 10 into 11. All right. Now 21 by 6 will give us 3 cancels 21 7 times and 6 2 times. So it is 7 by 2. We could have taken 10 also common, but no problem. 41 into 20 is 820. 41 into 20 is 820, right? Minus 11 into 10 is 110. So we will have 7 by 2 into 820 minus 110 would be 710. Now 2 cancels 710, 355 times. So the answer would be 7 into 355. Multiply that. 7 5s is 35, 3 carry. 7 5s are 35 plus 3 38, 3 carry. 7 3s are 21 plus 3 is 24. So 2485 is the answer of this question. You need to find the suitable option. Alright, now let's take up next question, question number 16. It says 9 plus 3 by 4 plus 7 plus 2 by 17 minus, now be careful, it is 9 plus 1 by 15 and the whole thing is in bracket. Okay, right? Now let's see. Now this 9 and this minus 9 will get cancelled. We will have 3 by 4 plus 2 by 17 minus 1 by 15 plus 7. So what I have done is I have cancelled integers wherever possible and kept the integers separate and fractions separate. Alright. Now take LCM in the first three. So LCM of 4, 17 and 15 would be 1020 because there is nothing common. We have to simply multiply. Then let's say if LCM is 1020, now 4, it will become 255. So 255 into 3, that is 765. You have to do the normal addition process, fraction addition process. Plus 17 6 is 1020. So 16 to 2 is 120. Minus 15 would cancel 1020 68 times. So 68 plus 7. Now 765 plus 120 is equal to 885 minus 68, that is 817. So the final answer is 817 upon 1020 plus 7. You need to find the suitable option, that is D option. Be careful in choosing the correct option. Alright. So this was a simple question of simplification process. Now question number 17. It says 1 minus 1 upon n plus 1 minus 2 upon n plus 1 minus 3 upon n and this goes up to n terms. So I'll write the nth term as 1 minus n upon n and let it be like that. Okay, now let's see. Separate them as we did in the last question. Add all the integers. If you look at it carefully, 1 is the integer part in all n parts. So there are total n parts and each part has a 1. So the total sum of those 1s will become 1 into n. Now the remaining parts all are negative, so take minus sign comma. And inside the bracket you will have 1 by n plus 2 by n plus 3 by n up to n by n. Look at it again. Every number, every bracket here has 1 in it. So we have added all the ones together because they're all positive. So n times 1 will become 1 into n. Now all the remaining fractional part have negative sign before them. So we have taken minus sign common. And inside the bracket we have kept 1 by n, 2 by n, 3 by n up to n by n. Now see, 1 into n is n minus, if you take LCM, all have n in them, and in the numerator it will become 1 plus 2 plus 3 plus up to n. We have already seen the sum of natural numbers from 1 to n is n into n plus 1 by 2. So it is n minus n into n plus 1 by 2, and in the denominator we already have n. So what will happen? This n gets cancelled by this n. So we will have n minus n plus 1 by 2. Then take the LCM as 2 and simplify. So it is 2n minus n plus 1. So it is minus n minus 1. So 1n gets cancelled out and we will have our final answer as n minus 1 upon 2. So be careful and find the suitable option. So it is n minus 1 upon 2 is the final answer. So half of n minus 1 is the answer, that is option B. As I can see, it is option B. It is half of n minus 1. Alright, only half of n minus 1. Now the next question, question number 18. It says 1 square plus 2 square plus 3 square up to 20 square. We have just used the formula for sum of squares of natural numbers in one of the previous questions. You can directly apply. It is 20 square. So it is, we know that formula is n into n plus 1 into 2n plus 1 upon 6. Put n equal to 20 in this. So it is 20 into 21 into 41 divided by 6. 3 cancels 21 7 times, 3 cancels 6 2 times, 2 cancels 20 10 times. So 10 into 7 into 41. So it is equal to 2870. So the answer of this question is 2870. Find the suitable options. It is C. Now question number 19. It is 10 cube plus 11 cube plus 12 cube up to 20 cube up to, this is 13 cube up to 20 cube. Now this again is similar to the question that we have done earlier. It starts from 10, goes up to 20. Now here, if we had we have a formula for cube, sum of cubes, that is 1 cube plus 2 cube plus 3 cube up to n cube, and that formula is n into n plus 1 upon 2 whole square, right? N into n plus 1 upon 2 a whole square. This is the formula for sum of cubes. But here it doesn't start from 1. Our condition is it should start from 1. So what do we do now? Let's do one thing. Let's add the cubes of 1 to 9 and subtract cubes of 1 to 9, right? So I'll write it like this: 1 cube plus 2 cube up to 9 cube I'm adding, and whatever was there already I'm writing them. So 10 cube up to 20 cube. Okay. Minus, we have added 1 cube to 9 cube. So subtract 1 cube plus 2 cube up to 9 cube. So what we have done is we have added the cubes of numbers from 1 to 9 and subtracted the cubes from 1 to 9. What is the benefit of this? The first part becomes cubes of 1 to 20. So we can apply the direct formula, that is n into n plus 1 by 2, by putting value of n equal to 20 in the first part. So it is 20 into 21 by 2 whole square. Minus, for the second one we'll use the same formula because it is sum of cubes, but we'll put n equal to 9. So it is 9 into 10 divided by 2 whole square. Now 2 cancels 20 10 times, 10 into 21 is 210 and 210 square is 44100 because 21 square is 441. So 44,100 minus 2 cancels 10 5 times. So it is 9 5s are 45 and 45 square is 2025. Alright. So 44,100 minus 2025. Okay. This becomes, if you subtract, it will become 75 in the end and 440 minus 20, so it is 420. So 42075 should be the answer. Find the suitable options. I think it is option D, none of these. So D should be the answer. All right. Now the next question, question number 20. It says 2231 divided by 2921. Now in this situation, it is slightly difficult to identify what number is it going to be divisible with. All right, but you can work with the options and eliminate them. For example, in the options, in numerator there is either 93 or 97. Now 93 is a divisible by 3 and that is there in the numerator. That means the original number must be divisible by 3. Original numerator must be divisible by 3. Let's check. So 2231, that is 2 plus 2, that is 4 plus 3, 7 plus 1, that is 8. It is not divisible by 3. Hence, in the answer, we cannot have 93 in the numerator. Alright. So the first option, let's take up options one by one. 93 upon 124. B option is 97 upon 127. C option is 97 upon 123. And D option is 93 upon 127. All right. Now see, in option A and in option D, we have 93 in the numerator. That is the answer after simplification. 93 is divisible by 3. So if the original number, numerator should be divisible by 3. Check the numerator, 2 plus 2, 4 plus 3, 7 plus 1, 8. It is not. So A cannot be the answer, D cannot be the answer. Alright. Now in B and C, both the options, 97 is there in the numerator. So no need to check further. Now look at the option C. In the denominator, 123 is divisible by 3. Let's check the denominator of the original number. That must be divisible by 3. So 2 plus 9, 11 plus 2, 13 plus 1, 14. It is not divisible by 3. So C cannot be the answer. Hence we are left with only one answer, that is 97 upon 127. Alright. So with the checking of divisibility by 3, you could have done this question. Alright. Now the other method, which is the conventional method for this question, what you could have done was find the common factor using the long division method. Alright. So let's take it like this: 2231 and 2921. This is the method of finding HCF with the long division method. Okay. So first we take one time, that is 2231, and subtract. We get 1 minus 1, 0. This is 12 minus 3, that is 9. This 8 minus 2 is 6. So it is 690. 2231 becomes the next dividend. Alright. Now 690 into 3. So this will be 30. 3 9s are 27. 7 to carry forward. 3 6 are 18 plus 2, 20. So 2070. So 1, 13 minus 7 is 6. And 1 minus 0 is 1. Now 161. Now 690 becomes the next dividend. 161 would be 4 times. So it is 644. If you subtract, you get 46. Now 161 becomes the next dividend. 46 and 161. So it is 3 times. 46 3s would be 138. And if you subtract, you get 23. Then 23, and it divides 46. It is twice 46, and we get a remainder 0. The step in which we get remainder 0, in that case, whatever was the divisor will be the common factor. So the common factor, or you can say the highest common factor of those two numbers, is 23. Right? Now to simplify, 2231 upon 2921 can divide by 23. Alright, so if you divide by 23, numerator will become 23 into, let's say it will be 97, and if you divide the denominator by 23, it would become 23 into 127. Right, so 23 gets cancelled and it is 97 upon 127. But that definitely is a little longer method. From the exam point of view, you could have just checked the divisibility and you could have found the answer. Okay. Now the next question is on the similar lines. Question is, reduce 391 upon 667 to the lowest terms. Let's again first go by the options. 17 by 12. B option is 12 by 17. C option is 17 upon 29. And D option is 93 upon 17. Now in the original question, numerator is smaller, denominator is larger. So that means option A, in which numerator is larger than denominator, cannot be the answer. Option D, in which numerator is larger, cannot be the answer. Now we are left with two options, 12 by 17 and 17 upon 29. Now B option is 12 by 17. Now 12 is an even number, so numerator is an even number. After simplification, it is even number. That means the original number also must be an even number, which is not. Hence, B also is the wrong answer. The only option left is C. Hence, C is the correct answer. Obviously, there will be trouble if there is an option, none of these also. Hence, you have to apply the other method as well. Let's see. Let's take a look at the other method. How does it go? Other method goes by finding the HCF of two numbers. So let's use the long division method. 391 divide 667. So it is ones. So 391. Subtract. You will get 6 here, and 16 minus 9 is 7. 5 minus 3 is 2. Now 276 divide 391. Alright, so it is ones. 276. Subtract. 11 minus 6 is 5, 8 minus 7 is 1, 3 minus 2 is 1. Then 276 goes twice, so it is 230. We are left with 46. The 46 divides 115, goes twice, so it is 92. Subtract, you get 23. And 23 divides 46 completely two times. Right? So the step in which remainder comes out to be 0, in that step, whatever is the divisor is the HCF. So HCF is 23. That means when you have to simplify, 391 upon 667 divide by 23 in both numerator and denominator. In the first one, if you divide by 23, you will get 23 into 1. So 161 is 17 times. And in the denominator, it will be 23 twice 46. 23 into 246, then 20. 207 is 9 times. So it is 29 times. So 23 gets cancelled and the final answer is 17 upon 29. Again, obviously you can see that checking the options was a better method. Now let's take up question number 22. It says, what is the smallest number of square tiles required to tile a room of dimensions 12 meter 65 centimeters? So let's say there is a rectangle shaped room. There is a rectangle shaped room and the length of that rectangle is 19 meter 80 centimeters. So if you convert it into centimeter, we know that 1 meter is 100 centimeter. So 19 meter will be 1900 centimeter plus 80 centimeter. So it becomes 1980 centimeter and the width would be, it is 12 meter 65 centimeters. So it becomes 1265 centimeters. Alright, so this is the rectangular base of the room. Now what we have to do is we have to find the smallest number of square tiles. Now how will the square tiles be placed? Look at the structure. We have to draw lines like this, and similarly we have to draw lines like this. Okay. Now look at one tile. This is one tile. I'll shade it for you. This is one tile. Okay. Now see, if you look at just one tile, what we need to understand that the length of this tile should be a factor of 1980. Similarly, the width of this tile should be a factor of 1265. Hence, it should be a common factor. Why? Because it is a square tile. So both the sides should be of same length, right? So that means of the square tile, side of the square tile has to be has to be a common factor of both length as well as breadth. All right. Now, also we need to find the smallest number of square tiles. That means the size of square should be the highest. For the number of tiles to be smallest, the size of square should be the highest. So we need to consider the highest common factor to be the side of square. So let's calculate HCF of 1980 and 1265. So you can calculate either by factorization or by highest or by long division method. Right now let's use factorization method. So 1980, if you factorize, it becomes 10 into 198, that is 20 into 99. So finally we have 2 square into 3 square into, it is 20 into 99, so 2 square into 3 square into 5 into 11. Similarly, 1265 would be equal to, it would be, if I divide it by 5, it gives us 253. Alright, so 5 into 253, so that is 11, 23 into 11, so it is 5 into 11 into 23. Alright, so HCF of these two numbers is equal to 5 into 11, which is the common factor. So 5 into 11 is 55. Okay, so 55 centimeter should be the side of a tile, of one tile. Alright, so side of the tile is equal to 55 centimeter. Alright, so the number of tiles, how will you calculate number of tiles? Number of tiles required would be equal to total area of the room, total area of the floor, divided by area of one tile, area of one tile. Okay, now total area available here is 1980 into 1265 divided by area of one tile would be 55 into 55. So if you divide 1265 by 55, you will get 23. As you can see from factorization, this is 55, this is 23. And when 1980 gets divided by 55, you will get 4 into 9, that is 36, and this is 55, so you get 36. That means the number of square tiles required would be 36 into 23. Alright. Now this is 36 into 23 is equal to, it is 720 plus 108. It is 828 tiles required. Now read the question carefully. If it is asking number of tiles would be equal to 828. And if it is asking the size of tiles, then it is 55 centimeter wide and 55 centimeter length. Okay, so I think there is some misprint in the question here, and whatever, you just check the question. If it is asking for number of tiles, then it is 828. If it is asking for the size of tile, then it is 55 centimeter. Alright, just be careful about it. Now question number 23, it says the greatest possible length which can be used to measure exactly the lengths 7 meter, 3 meter 85 centimeter, and 12 meter 95 centimeter. Let's express all of them in centimeters. So 700 centimeters, 385 centimeters, and 1295 centimeters. Alright, so these are the three lengths that we need to measure. I think it's very clear. The length has to be, length that can measure all of them should be a factor of all of them. Alright, so let's simply find HCF of all these numbers. So let's factorize all of them. 700 is equal to 2 raised to the power 2 into 5 raised to the power 2 into 7 raised to the power 1. 385, if you factorize, you'll get 385. If you divide by 5, it will be 77 into 5. So it is 5 raised to the power 1 into 7 raised to the power 1 into 11 raised to the power 1. Then 1295, if you factorize it, you'll get as it is 259 into 5. Alright, 259 into 5. So it is 5 into 259 can be divided by 7. So 5 into 7 into 5 raised to 1 into 7 raised to 1. You can factorize it on your own. 5 raised to 1, 7 raised to 1 into, if you divide 259 by 7, it will be 7 3s are and 37, right? So it is 37 raised to 1. So as you can see, the highest common factor for all the three numbers is 5 raised to 1 into 7 raised to 1, which is 35 centimeter. So the largest possible length which can be used to measure all of these lengths is 35 centimeter. This is question number 23. All right. Then question number 24. It says find the largest number which divides 62, 132 and 237 to leave the same remainder in each case. All right. So what we need to do is we need to find the largest number which gives the same remainder. That means if I divide 62 by a divisor D, we'll get some quotient, let's say Q1, plus a remainder R. Similarly, if I divide 132 by the same divisor and we get some other quotient, but the remainder should be same. And the third number is 237. We divide by the same divisor into we get some quotient and remainder R. Let's say we have these three equations, 1, 2 and 3. Okay, you subtract second from the third and first from the second. So let's say first from the second, that is second minus first. What do we get? R gets cancelled. 132 minus 62 will be 70 and it will be equal to D into Q2 minus Q1. Similarly, third minus second, if you do that, 237 minus 132, it will be 105 and it has to be D into Q3 minus Q2. Now see, look at this very carefully. 70 is equal to D into Q2 minus Q1. Hence, D has to be a factor of 70. Similarly, 105 is equal to D into something. So again, D has to be a factor of 105. All right. So D is very clearly a common factor of both 70 and 105. Okay. So I'll write it here. Question 24 continued. Okay. So that means D is common factor of both 70 and 105. All right, but we need largest such number, so we need to take the largest common factor, that is HCF. So D has to be HCF of 70 and 105. Now by factorization you can see 70 is 35 into 2, 105 is 35 into 3, so clearly D value is 35, right? So the required divisor or required number for this question is 35. Okay. Now, question number 25, it says A, B and C start at the same time in the same direction to run around a circular stadium. A completes a round in 252 seconds. B in 308 seconds, and C in 198 seconds. To take one complete round, A takes 252 seconds. So after every 252 seconds, A will be found at the starting point. Similarly, B takes 308 seconds to complete one round. So clearly, B will also be found at the starting point after every 308 seconds. C takes 198 seconds for one complete round. Alright, so C will be there at the starting point after every 198 seconds. After what time will they meet again at the starting point? Now, A will be at the starting point at any multiple of 252. So, 252 seconds or any multiple of 252 seconds. Similarly, B will be at the starting point after 308 seconds or at any multiple of 308 seconds. Let's say 308 M. Similarly, C would be at the starting point at after 198 seconds or any multiple of 198. Let's say 198 T. That means all the three together, when they are at the starting point again, it has to be a multiple of the time duration, has to be a multiple of time taken by A, that is 252, and time taken by B, that is 308, and time taken by C, that is 198. So we are looking at the common multiple of 252, 308, and 198. Alright. Okay. Now the question is saying they have begun. So for the first meeting at the starting point again, we need the first common multiple. So question is, after what time will they meet again at the starting point? That means we are talking about the first meeting after the beginning, right? That means we are talking about the first common multiple, which is also known as lowest common multiple, or in general LCM. So answer of all such questions will be the time for meeting at starting point. You can note it down and memorize. Meeting at starting point is always equal to the LCM of individual times. LCM of individual times to take one round. Okay, you can directly use this as a formula. The starting point meeting will always be the time duration for starting point meeting will be the LCM of individual time. So we need to find LCM of 252, 308 and 198, right? So whatever method you want to use, you can use. Let's use this method: 252, 308 and 198. Okay, so I think 2 is the common factor, so take out 2, you'll get 126, then 154, and then 99. Then out of still we can take no, 3 is not the common factor. Okay, now there is no common factor for all the three, because 126 is 14 into 9, 154 is 14 into 11, and 99 is 9 into 11. So there is no number which is common to all. So let's do one thing. Let's take 7 common from the first two. So if you take out 7 common from 126, you will get it is 18 sevens are 126. So we have 18 here, and 154 will give us 22. 99 will remain without effect. And from 18 and 22 you can take 2 common, so it will be 9, 11 and 99. Then you can take 9 common, 9 will become 1, 11 will remain 11, 99 will become 11, and then you can take 11 common, so nothing remains after that. So the LCM would be 2 into 7 into 2 into 9 into 11. So it is 2, 2s are 4, 7s are 28 into 99. So 2800 minus 28, it is 2772 seconds. So the time for starting point meeting is 2772 seconds. Now divide it by 60 to get in terms of minutes. Now 2400 would be 40 minutes. Now 372, so it is 46 minutes. 46 minutes and 12 seconds. So divide 2772 by 60 to get 46 minutes and 12 seconds. So the answer of this question is 46 minutes and 12 seconds. Okay. Now let's take a look at the next question, which says, question number 26. It says find the largest number of 4 digits exactly divisible by 12, 15, 18 and 27. Now, largest number we need to think later on. First, find the smallest such number. The smallest such number would be LCM of 12, 15, 18 and 27. Let's take 3 common. So we will have 4, 5, 6 and 9. Now there is nothing common to all of them. So take 2 common. So 4 will give us 2, 5 will remain as it is, 6 will give us 3, 9 will remain as it is. Now take 3 common. So we will get 2, 5, 1 and 3. Now there is nothing else common. So LCM would be equal to 3 into 2 into 3 into 2 into 5 into 1 into 3. You can do this calculation mentally also. Now this will be 3 into 2, 6 into 3, 18 into 3, 54 into 10, that is 540. So 540 is the first number which is exactly divisible by all of them. Now we need to find the largest 4-digit number. So what we need to do is, whatever answer will be a multiple of 540 because 540 is the smallest multiple. Now let's go closer to the largest 4-digit number, that is 9999. So we need to find a multiple of 540 close to 999. Now randomly 540 into 20, it will be equal to 10,800. Alright. So it must be 540 into 19, which will be 540 less than this. 10,800 is a 5-digit number, so that cannot be the answer. Alright. So if you 540 into 19 will be 540 less than 10,800. So it will be 10,000. Oh, still more than 10,000, but let's calculate it. It is 10,260. But it's still a 5-digit number. So the next one or the lower one would be 540 into 18. That would be 540 less than this number. So it is 2097. So it is 9720 is the largest 4-digit number which is divisible by all of these numbers because it is a multiple of 540. So this is our answer. Okay. Now question number 27. It says find the smallest number of 5 digits exactly divisible by 16, 24, 36 and 54. Still the same process. First find the LCM of 16, 24, 36 and 54. I think you can see that 2 is the only common factor. So if you take out 2, it will be 8, 12, 18 and 27. Then you can take out 3. 3 will give us 8, 4, 6 and it will be 27, 3 will be 9. You can again take out 2 or maybe 3 also. You can take out 2, so you will get 4, 2, 3, 9. So you can take out 2 again, so it will be 2, 1, 3 and 9 will remain as it is. You can take out 3 again, so it will be 2, 1, 1, 3. So the required LCM would be, after multiplying all these numbers, you can get 2 into 3, 6 into 2, 12 into 2, 24 into 3, 40, 72 into 2, 144 into 3, 432. I repeat, 2 into 3 is 6 into 2, 12 into 2, 24 into 3, 72 into 2, 144 into 3, 432. So the smallest number is 432. Now we need to go closer to the value 10,000 because we need to find the smallest number of 5 digits. So the smallest number of 5 digits would be very close to 10,000. Let's look at any multiple of 432 close to 10,000. I think it would be 21 or 25 times maybe. So 432 into 25 directly, if you calculate, it will come out to be, let's see, 25 twos is 50. So 0. Then we get 5, 25 3s are 75 and 5 80. So 0, 8, 25 4s is 100. So 108. So it is 10,800. You know, just on the hunch, 432, 400 into 25, so it will be close to 10,000. By thinking that, we got it that way. Now it is 10,800. Very clearly, 800 is close to double of 432. So let's take 432 into 23. I think that will come down, or that will come below 10,000. No, that will go below 10,000. Right? Let's calculate it. 23 twos are 46. So 6 here, 4 carry, 23 3s are 69 plus 4, 73. Alright. So it is 3, 7 carry, 23 4s are 92 and 7, 99. So it is 9936. Now this is below 10,000. Okay. So that means our answer would be 432 into 24. So with a little bit of practice, you will get direct. Now let's take up question number 28. It says, find the largest 5-digit number divisible by 9, 12, 15 and 27. So the first thing that we need to find is the smallest such number which is divisible by all of them, and that will be LCM, right? Take LCM of 9, 12, 15, 27. First take 3 common, divide 9 by 3 you get 3, divide 12 by 3 you get 4, divide 15 by 3 you get 5, divide 27 by 3 you get 9. Then out of 3 and 9, 3 is common, so you get 1, 4, 5 and 3. Multiply all of them to get LCM, and that would be equal to 3 into 3, 9 into 4, 36 into 5, 180 into 3, 540. So 540 is the smallest number which is divisible by all of these numbers. Okay. Now we have to find a number, largest number of 5 digits like this. Okay. Now see, 540 into 200, it is, let's check how it comes out to be. We have to get close to, largest 5-digit number is 99999. Okay, we have to get close to this number, and that should be a multiple of 540. So how do we do that? Let's take it like this. Let's say 540 into 200. Let's first check how much does this come out to be. It would be 108,000. But this is a 6-digit number, so we need to subtract 10 times 5400. No, that 10 times 540 would be 5400. Here it is 8,000 above the requirement. So what we do is we take 15 times would be 8100. Right, so 540 into 18 into 15. This will come out to be 5400 plus 2700, that is 8100. Alright, so what you need to do is you subtract 1,08,000. It's 1,08,000. Subtract 8,100. So it will be 540 into 185, and that will be 1,08,000 minus 8,100. Right? I hope you understand. It is 540 into 200. We are subtracting 540 into 15. So what do we get? We get 540 into 200 minus 15, that is 185, and that will be 1,08,000 minus 8,100. So it is 99,900. Okay, 99,900. This is the largest 5-digit number which is divisible by 540, and hence it is divisible by all the given numbers. Alright. Now the next number, question number 29, it says find the smallest 3-digit number divisible by 12, 16, 24 and 36. So first take the LCM of these all numbers. Now first we take the common of all these, common factor of all these numbers is 4. So 4 divides 12 3 times, divide 16 4 times, divide 24 6 times, divide 36 9 times. Now we take 3 common. So 3 gives us 3 gives us 1. 4 gives us 4, 6 gives us 2, 9 gives us 3. Now out of 4 and 2 you can take 2 common. You will have 1, 2, 1, 3. So LCM, required LCM would be equal to 4 into 3, 12 into 2, 24 into 2, 48 into 3, 144. So the smallest 3-digit number is 144, which is divisible by 12, 16, 24 and 36. So the answer of this question is 144. Now let's take question number 30. It says the least multiple of 7 which leaves a remainder of 4 when divided by 6, 9, 15 and 18. Now in this question, if you use options, it will be much easier, right? Because the options are smaller. See, you can use options when they're usable. Now usable means the numbers have to be small. Okay, So let's take question number 30. It says the least multiple of 7. So our first condition is the number should be a multiple of 7. Now option A, 74. You can see it is 70 plus 4. Hence it is not a multiple of 7. So this cannot be the answer. Then option B is 94. 94, if you divide by 7, it is 91 plus 3. So it is not divisible by 7. So this cannot be the answer. Then C option is 184. Check whether this is divisible by 7. You can normally divide. So 7 2s are 14. 44 is not divisible by 7. So this also is not divisible by 7. Alright, now let's see option D. It is 364. Now, because there is no other option, hence 364 has to be the correct answer. Alright, but let's check for our satisfaction. 364, if you divide by 7, 7 5s are 35, 14. So it is divisible by 7. So on one account it is correct. Now let's check whether it leaves a remainder of 4 when divided by 6, 9, 15 or 18. So if you divide 364, 360 is divisible by 6. In fact, 360 is divisible by all 9, 15 and 18 also. Hence the remainder will be 4 in all cases. Hence the correct answer is 364. Okay. Now let's take question number 31. It says find the least number which when divided by 5, 6, 7 and 8 leaves a remainder 3, but when divided by 9 leaves no remainder. Now in this question you see that it has 843, 1683, 840 and none of these also. So here it will be a little difficult to use options. So let's go by the normal method. Okay. So first what we do is first we calculate LCM of 5, 6, 7, 8. Alright. So the LCM of 5, 6, 7, 8 to calculate that you take 2 common. So you get 5 here, 3 here, 7 here and 4 here. So the required LCM will come out to be 2 into 5, 10 into 3, 30 into 7, 210 into 4, 840. Right? Now 840 is divisible by all of 5, 6, 7 and 8. But we need a remainder of 3. So our required number should be 840k plus 3. Right? So any such number when you divide by 5, 6, 7 or 8 will always give a remainder of 3 because 840 will be divisible by any one of them. But we need a number which is completely divisible by 9. Right? Now if you take the numbers like this, let's say 840 into 1 plus 3. So for example it is 843. 840 into 2 plus 3. This would be equal to 1680 plus 3. So it is 1683. 1683. Alright. Similarly, if you take 840 into 3 plus 3, you will get 2520. So 2523 and so on. Now out of all such numbers, we need to find the one which is divisible by 9. Let's check the first number. It is 8 plus 4 plus 3, 15. So it is not divisible by 3. Let's check the second number. 1 plus 6 plus 8 plus 3, that is 7 plus 8, 15 plus 3, 18. Right? So this is the first number which is divisible by 9 in this case. So our answer of this question would be 1683. Right? You have to go on checking like that to find the correct answer. Okay, so answer of that question would be 1683. Okay. Now let's take question number 32. It says the sum of two numbers is 216 and their HCF is 27. HCF is 27. So the numbers can be taken as 27x and 27y because we have to take two numbers and their highest common factor is 27. Right? So basically what it means is the first number can be taken as 27 into x. X can be anything. And the second number can be taken as 27 into y. Y can be anything. The only condition is the highest common between 27x and 27y should be only 27. That means x and y should not have anything in common. Now their sum is given equal to 216. So if you divide by 27, this equation will become x plus y is equal to 8. So the possible values of x and y would be 1 and 7. You cannot take 2 and 6 because 2 and 6 will have 2 as a common factor. We have already said that x and y cannot have any common factor. I repeat, the numbers are 27x and 27y and 27 is the highest common factor. So there should not be anything common other than 27. That means x and y should not have anything common. So 1 and 7 is one possibility. Similarly, 2, 6 is not possible. 3 and 5 is another possibility, right? 4 and 4 is not possible. So the possible values of x and y are 1, 7 or 3, 5. Now in this case, if you multiply by 27, you remember these are the values of x and y. So the numbers are 27x and 27y. So the possibilities are, for the first case, 1 and 7, the possibilities will be 27 into 1, that is 27, and 27 into 7, that is 189. This is one possibility. The second possibility will be 27 into 3, that is 81, and 27 into 5, that is 135. This is the second possibility. So there are two possible pairs. If you look at the options, there is first option is 27 and 189. So the answer of the question would be 27 and 189. You could have also solved this question with the help of options, right? If you look at the option, first option, if you add 27 plus 189 is 216, so it is a possible answer. Second option, 81 plus 189, it goes beyond 216, so that cannot be the answer. C option is 108 and 108. Numbers are equal, so HCF should have been equal to 108. Hence, that is a wrong option. Fourth option, 154 plus 162. The addition goes beyond 300, so that can also not be the answer. Hence, answer is A. So this way, you could have used options also. All right. Now comes question number 33. It says the LCM of two numbers is 495 and their HCF is 5. So let's take the numbers to be 5x and 5y. Now calculate LCM of 5x and 5y. So as we said, 5 is the highest common factor. So if you take out 5, there will be nothing common. Hence the LCM would become 5 into x into y. And that LCM is given 495. So 495 is equal to 5 into x into y. Just be careful that x and y should not have anything common. Now if you divide by 5, you will get x into y equal to 495 divided by 5 would be 99. Just keep in mind that there should not be any common factor between the numbers. So x into y is 99. So the possibilities are 1 into 99 or 9 into 11 or 99 into 1 or 11 into 9 or 3 into 33. So these are the three possibilities. But 99 into 1 is same as 1 into 99. 11 into 9 is same as 9 into 11 and 33 into 3 is same as 3 into 33. So it doesn't matter. Alright. Now there is another condition that says the sum of the numbers is 100. So that means 5x plus 5y is equal to 100. This is the other condition. So if you divide by x, you will get x, divide by 5, you will get x plus y equal to 20. So if you validate the three things or three situations that we had, 1 and 99 will not add up to 20. 9 and 11 will add up to 20. 3 and 33 will not add up to 20. So we get a clear-cut situation here that the value of x and y can be taken as 9 and 11. Hence the numbers which are 5x and 5y can be taken as 5 into 9 is 45 and 5 into 11 is 55. So the required difference of these two numbers would be 55 minus 45, which is equal to 10. So the answer of the question is 10. Okay. Now let's take question number 34. It says the ratio of two numbers is 15 is to 11. Now do you remember how do we calculate ratio? We calculate ratio by cancelling the highest common factor. And that is 15 upon 11. That means we have already cancelled highest common factor and then we got 15 and 11 for the numbers. And here is given that HCF is 13. Alright. This means the first number has to be 15 into the 13 value, which is equal to 195. Okay. And similarly, the second number B has to be 11 into 13, which is equal to 143. So the numbers are 195 and 143. As you can see in one of the options, it is there. Okay. Then we come to question number 35. It says find two numbers such that the sum is 180 and HCF is 45. So let's straight away take the numbers to be 45x plus 45y. That is equal to 180. Remember, x and y should not have any common factor. So if you divide by 45, you will get x plus y is equal to 4. The only possibility will be 1 plus 3. Alright, so the numbers are 45 into 1, hence 45, and 45 into 3, hence 135. You have to be careful because none of these option is also there. So the answer is 45 and 135. Okay. Then we have question number 36. It says find the two numbers whose LCM is 504 and HCF is 7. HCF is 7, so take the numbers as 7x and 7y. First relation is the sum is 119, so 7x plus 7y is equal to 119. Divide by 7 to get x plus y equal to 17. So one equation is x plus y equal to 17. Now it says their LCM is 504. Now calculate LCM. 7x and 7y. We know that 7 is the highest common factor. So if you take out 7, remaining would be x and y and nothing common between x and y. So LCM will be equal to 7 into x into y. And it is given that LCM is 504. So 504 is equal to 7xy. So if you divide by 7, you will have x into y is equal to 72. So we already have x plus y equal to 17 and x into y equal to 72, and there cannot be any common factor between x and y. So if you break 72 in two parts as a product, it will be 1 into 72. You cannot take 2 into 36 because 2 is common. You cannot take 3 into 24 because 3 is common. You cannot take 4 into 18 because 2 would be common in 4 and 18. Then 5 you can't take. 5 is not a factor of 72. 6 into 12, 6 would be the common factor. 7 is not a factor, so 8 into 9 is the next possibility, right? So 8 into 9 is the one possibility and 1 into 72 is the other possibility. Then we check the condition of sum. Now 1 plus 72 is 73 and 8 plus 9 is 17. So very clearly we can see that 17 is the correct possibility. So 8 and 9 are the values of x and y. So the numbers are 7x, so 7 into 8, which is 56, and 7y, that is 7 into 9, that is 63. So the final answer of the question would be 56 and 63. These are the two numbers. Now the next question is same as one of the previous questions. Question number 37. It says two numbers are in the ratio 7 is to 13. So it is 7 by 13. So ratio must have been calculated after cancelling the common factor, highest common factor. And is already given that HCF is 11. So straight away the numbers can be taken as 7 into 11, which is 77. And second number can be calculated as 13 into 7, which is 91. Alright. So numbers are 77 and 91. Sorry. I'm sorry, it is 13 into 11, which is equal to 143. Alright. So the answer is 77 and 143. Okay. Now question number 38. To do this question, first let's recall there is a formula that is a cube minus b cube is equal to a minus b into a square minus ab plus b square. This is one formula of factorization of a cube minus b cube. Now in this question, if you look at this, it is a minus b into a square plus ab plus b square, right? Similarly, there is a formula a cube plus b cube, which is equal to a plus b into a square minus ab plus b square. Alright, so these are the two formula that we have already. Okay, if you don't remember, you can memorize it from here now. Now in this question, let's consider 753 as A and 247 as B. Okay, 753 as A and 247 as B. So I'll write the question here, 38 continued. I'll write it here. So I'll first write the expression given in the question. It says 753 into 753 plus 247 into 247 minus 753 into 247 divide by 753 into 753 into 753 plus 247 into 247 into 247. So this expression becomes, look at this, we have taken 753 to be A. So it becomes 753 into 753 becomes A square plus 247 into 247 becomes B square minus 753 into 247 becomes A into B. Now 753 into 753 into 753 becomes A cube plus 247 into 247 into 247 becomes B cube. So in the numerator we have, I'll just rearrange A square minus AB plus B square, and in the denominator we have A cube plus B cube. So if you factorize, you will get A plus B into A square minus AB plus B square. Now A square minus AB plus B square, the whole expression gets cancelled from numerator, and we shall have simply 1 upon A plus B. Now put the values of A and B back, so you'll get 1 upon 753 plus 247. So the final answer of the question is 1 upon 1000. Okay, this is the answer of this question. Now similarly, for question number 39, you have the expression as 963 plus 476 whole square plus 963 minus 476 whole square divided by 963 into 963 plus 476 into 476. Now for this question, let's consider 963 to be A and 476 to be B. Now I hope you remember the squares formula, that is A plus B whole square is equal to A square minus 2AB plus B square. And A plus B whole square is A square plus 2AB plus B square, and A minus B whole square is equal to A square minus 2AB plus B square. If you add these two, see what you get. If you add these two, A plus B whole square plus A minus B whole square will come out to be 2AB and 2AB will get cancelled. So you will have 2 times A square plus 2 times B square, hence 2 times A square plus B square. Okay. Now come back to the question. It says 963 plus 476. So we can take them as 963 as A, 476 as B. So A plus B whole square plus 963 as A and 476 as B. So it is A minus B. The second part is A minus B whole square. Divide by 963 into 963 is A square plus 476 into 476 is B square. Just now we saw that A plus B whole square plus A minus B whole square is 2 times A square plus B square. And the whole divide by also A square plus B square. So this A square plus B square term will get cancelled completely. So what we are left with is 2. So the answer of the question would be 2. Alright. Now let's take question number 40. It says 767 into 767 into 767 plus 233 into 233 into 233 divided by 767 into 760. So straight away we take 767 as A and 233 as B. Now look at the given expression. It is 767 into 767 into 767. So it becomes A cube. Let me write the expression first. 767 into 767 into 767 plus 233 into 233 into 233 divide by 767 into 767 minus 767 into 233 plus 233 into 233. Now this can be written as A cube plus B cube, because 767 is A, so A into A into A is A cube, divided by A square minus AB plus B square Just now in one of the previous questions we said that AQ plus BQ can be factorized as A plus B into A square minus AB plus B square, and the whole thing divided by A square minus AB plus B square. So the second part gets cancelled. So what we are remaining with is simply A plus B, which is 767 plus 233, and the final answer is 1000. Alright, so the answer of this question is 1000. Now we come to the last question of the exercise, question number 41. It says n is a number that on being divided by 3, 4, 6 leaves a remainder of 1, 2, 4 respectively. Right, so when it is divided by 3, the remainder is 1. When it is divided by 4, remainder is 2. When it is divided by 6, remainder is 4. Look at the difference of divisor and remainder. In the first case, it is 3 minus 1, that is 2. In the second case, it is 4 minus 2, that is again 2. And the third case, it is 6 minus 4, that is again 2. Now, in such cases where the difference of divisor and remainder is same, what you need to do is find the LCM. So let's find the LCM of divisors, right? So LCM of divisors in this case would be equal to LCM of 3, 4 and 6. You can calculate it, it will come out to be 20, 3, 4, 6 LCM will be 12. Alright, so LCM is 12. Okay, right? Now, whenever the difference of divisor and remainder is same, the numbers can be taken as, whenever the difference of divisor and remainders are same, we can take the number, our required number, to be LCM times something minus the difference. Okay, so minus the difference, right? So our number is of this structure, 12k minus 2. Now what do we need to do? We need to find the smallest 4-digit number. Now the smallest 4-digit number with the structure of 12k minus 2 would be very close to 1000, right? So let's try to find a number which is close to 1000 and it is divisible by 12, right? Just by tables you can see that the nearest number to 1000 which is divisible by 12, let's say 960. 12 8 is 96, so 960. Then 960 plus 36, it is 996. They're all divisible by 12. So the next multiple of 12 will be 996 plus 12, that is 1008. So 1008 is a number, this is divisible by 12, minus 2 is our correct answer because we need to find the smallest 4-digit number. So the answer of the question is 1006, and hence none of these in this question. Okay, so the answer of this question would be none of these. So the important thing for this question was, whenever the difference of a divisor and the remainder are same, you can take the number to be LCM times something minus the difference. Alright, and for that matter, so here the LCM was 12. So go for a multiple of 12 which is close to smallest 4-digit number 1000, that is 1008, minus 2, that is 1006 should be the answer of this question. Okay.